Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try out a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/Linode today, that's Linode, and get a $60 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. You listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For more opportunities to stay up to date, gain new skills, and learn from your peers, there are a growing number of virtual events that you can attend from the comfort and safety of your own home. Go to pythonpodcast.com/conferences to check out the upcoming events being offered by our partners and get registered today. Your host, as usual, is Tobias Macy, and today I'm interviewing Stephen F. Lott about finding a project that you care about to aid in learning to program. So, Stephen, can you start by introducing yourself?
Hi, Stephen Lott here. I'm a Python developer, been doing this for many years, since the previous century, really. I'm an author of a bunch of books through Pact Publishing.
And do you remember how you first got introduced to Python?
It is an odd thing because it happened a long time ago. I was a Java programmer back in the day when Java first came out, like I say, the previous century. And one of the questions that had come up was, is there a good alternative to Java? And I was a traveling consultant. I did technology consulting. And, the question is always, what's the next big thing? Capital letters, NBT. And what would overtake Java? And Python, back years ago, interested me a great deal because it looked like it would possibly be a thing that was an alternative to Java. And back in the day, your choices were Java and C++, and, languages like Eiffel, which never went very far, and Modula 3, which actually is a little bit of Python. But, getting those to run on your home computer in 1977 was just a nightmare. These were not really viable things. Python, quick download, up and running, did everything I wanted. Wow, it was wonderful. And then moving into the new millennium, the one we're in now, I used Python more and more for small consulting projects. And like I say, I was a traveling consultant, so there were a lot of small projects. And every time I wound up wrestling with somebody's poorly structured data, I used Python. One of the biggest ones that I wrestled with was a legacy COBOL application, thousands and thousands of lines of COBOL code that had to be looked at to figure out how you could best rewrite it. That was the worst structured data ever because it was source code in another language. And then, after those sorts of things, I wound up using Python more and more for development and things like that.
You also mentioned that you have authored a number of different books. I'm wondering what got you into that role of writing books and being an author and going through that whole process.
The book writing business is a strange thing because I sort of fell into it. I don't even know sort of whether you could call it like a sideways stumble into the business. The problem I had was that I was working on doing some development of a fairly complicated RESTful API in Python. It involved actuarial work and actuaries and a fair amount of thinking, and the test cases were very, very complicated. So the unit test suite ran for like 5 minutes and it was boring. So I started playing with Stack Overflow. And this is in the early days of Stack Overflow. This is the first year Stack Overflow was available to the public. So I started answering Python questions there because I had time to kill, 5 minutes while tests were running several times a day. And as a consequence, I built up a fair number of points in Stack Overflow. It's kind of a surprising number at this point in my career. And a Pact acquisition editor asked me, do you have anything more to contribute than just sort of random answers on Stack Overflow? And the answer was I did, but it was not like I sought out to become a published author. I kind of stumbled into it inadvertently. But because I was a traveling consultant, to the whole idea of, oh, wait, I've got a book and I'm an author and I can then travel around and shop around Python ideas to enterprise consumers was very, very appealing. And so I definitely pursued that as quickly as I could because it sounded like it was a lot of fun and a really good career move.
Yeah, it's definitely useful to be able to have some published body of knowledge that you can point to as signaling your expertise in a particular area, because it's easier to demonstrate that through publication, particularly to people higher up in an organization, as opposed to pointing at all of your open source contributions or the projects that you maintain, because they're not going to care as much about that, and they're not going to be in a position to be able to evaluate that for its overall effectiveness or usefulness.
Exactly. Until your open source contributions are, a GitHub project with thousands of stars, there isn't a lot of vetting, at least not the way there is in the publishing business. So the books all have technical reviewers. Then the technical reviewers have looked at every single line of code, every example, and complained about everything they can possibly complain about. And most of the technical reviewers, when you look inside the packed publications, are pretty heavy-duty experts in their own right. And so getting past those arguments really polishes up the text a lot. But with an open source contribution, did everybody really read all that code? Not necessarily. For big projects, yes. And for very popular projects, yes. But for small projects, maybe, maybe not.
In addition to your work as an author and as a traveling consultant, you also do some training, I understand, and you've created some of your own projects. I'm wondering if you can just give a bit more of an outline of your overall experience, both working with and teaching Python.
I'm actually not a traveling consultant anymore. I was when I started writing, but I left that. I lived on a sailboat for a couple of years. And then I now work for Capital One entirely in-house. And so the training is very much focused on my colleagues at Capital One, many of whom are data scientists, some of whom are DevOps and other more technical people. And so the training is very focused on needs we have at Capital One for specific kinds of Python skills. And in a lot of cases, there's a sort of a gap here because I'm not a real data scientist, and I'm sometimes not even qualified to talk about the difference between a mean and a median because I'll get those things confused in a room full of real data scientists. So my focus is on the technical side of programming and algorithms and data structures and Python and those kinds of things, the things I really know well. And we have to work collaboratively with the data scientists so that I don't completely mess things up and have them all storm out of the room in a huff because I said something extremely dumb about data science. Usually they're polite about it, but occasionally there'll be a break and they'll say, you really shouldn't, you really shouldn't confuse, some of these topics that you're not clear on. So that's always been very, very helpful, wonderful advice. But finding examples where I can meet my data science colleagues halfway is occasionally challenging. But because I lived on a sailboat, I did a fair number of things that involved data gathering and data analysis and data reduction. It was just on a very small personal scale, not the scope of the things the data science community does, but tiny things. And so some of my tiny examples are not completely wretched, and they like them. And so that works out really, really well. One of the ones that was a lot of fun for me and has been fun for my colleagues is when I rewired the alternator on the diesel engine. And what happens is the little pulses that show RPMs are now at a slightly different rate from the new alternator than they were from the old alternator. So I had to do a little data science thing to model the differences in the pulses. And it's embarrassing because I only have like 6 data points in the data set, but it does fit a line very elegantly. And we can use that tiny little data set to explore functional programming topics in Python where we can focus on the programming side of it because the data is small, relatively neat, doesn't involve account numbers or any of the other kinds of protected data that we have at banks. And so it's a fun project for them to deal with also, although at the time when I was working on it, it was brain-scramblingly complicated because I'm not a data scientist. But the functional programming aspect of it worked out beautifully well, and it serves as kind of a nice little example of how to apply Python functional techniques to a small set of data.
And that brings us nicely to our overall topic of how to find useful projects and useful motivations for people who are new to programming or who are acquiring new skills to help them stay focused and stay dedicated to actually acquiring the information that they're setting out for, while also being able to produce something useful to themselves. So I'm wondering how your overall day-to-day experience as somebody who is training other engineers in your work context helps you to identify useful ways that newcomers can learn about Python or acquire other technical skills.
It is a delightfully difficult problem because people have a variety of passions, different things interest them. The things that are important in the workplace sometimes aren't terribly motivating. And so, yes, it's an important project, and yes, the company will save money or make money or something, but really, frankly, it's can be kind of boring. And so some of those things can be frustrating for people who are expected to pick up a new skill, and some of it can be frustrating for managers who would like their people to pick up new skills. So it's fun to step outside the work environment. The tricky part about finding a passion project, one tricky part is that some things are just hard to automate. It's not so much that the software might be particularly difficult to write. Maybe the software is not that bad, but the whole concept of automating something can be really difficult. So because I lived on a boat, one of my passions is to limit agricultural runoff of pesticides and fertilizers. That's not really a very automatable thing. What am I going to do? Go give farmers better software? No, they have pretty good software for managing these things. What they don't necessarily have is perhaps the right regulatory environment for limiting where and when they can use pesticides. And is that an automation thing? Maybe it's not. Maybe it's just I need to call a lot more senators and representatives. So the passion that you have may not always fit something that can be automated in the first place. So that's one of the limitations, is to get the sort of language of automation and the approach to automating things so that you can have a respectable, doable project. And the second part, which is no less important, is sometimes it's just difficult to build good automated solutions. Software is, well, frankly, hard, and robust, scalable, reliable software is really hard. And so you may have some clever automated small app that runs on your desktop and may help the project that you're passionate about. But can you turn this into something that will scale and can be run in the cloud and can be deployed automatically? Oh, gosh. There's a whole lot of other considerations there outside the language, outside the value created by your project that can make it just daunting. And so you have am I doing the right thing? And am I doing the thing the right way? And there's both of those can be difficult to discover whether or not you've got the right thing, whether or not you're doing it the right way. And so when someone is learning technology for the first time, you're trying to learn the Python language, oh gosh, you kind of have to set both of those things aside. And you wind up having to build something that maybe isn't a great solution, doesn't solve the problem you're passionate about, but it maybe comes close. And that's important. That way you have something you're interested in. Maybe it's not the best ever solution, but it's better than nothing. And you learned the Python, and you learned more about automation, what can be automated, what can't be automated. And so the final bit of this is giving yourself permission to fail. It may not work. Things didn't work out right. That's okay. You started again. The second one was better than the first one. And that, I believe, is where the real secret is giving yourself permission to fail, to try something, to see if it worked. And if it didn't work, try something different. That, I think, is really important.
And there are a couple of things that I want to dig into there. One being that in terms of being able to select a project that you care about and that is motivating for you to go through the pain of learning this new skill, there's the difference of, as you said, what is possible versus what is practical versus what is not even achievable because of limitations of our current technology. But then there's also the learning to fail and fail effectively piece where there's failure in terms of the overall project, but then there are also the intermediate failures that happen as you're learning something where you have a syntax error and the project crashes, or there's a difference in the way that you implemented a particular function call versus what it's expecting, and being able to parse through those stack traces to understand what went wrong, how to fix it. What are your thoughts on some of the ways that the language itself and various ecosystem components, such as libraries or tool chains or editor environments, can assist in helping people to overcome those intermediate failures so that they can keep progressing rather than getting discouraged and giving up because they feel like they're not able to make forward progress?
Fighting the sense of discouragement from new technology is potentially quite difficult, and it is sort of daunting. It's sometimes difficult to figure out how to build up the right level of patience with all of this, because it is, especially when it's new, it is difficult. What I suspect sometimes is that folks who seem to struggle a lot, I believe, seem to struggle partly because, I hate to beat this point too heavily, but I think there are people who don't really feel comfortable giving themselves permission to fail. They'll try something, it didn't work, and they're not sure what to do next. And perhaps they need to back off some of their assumptions, back off some of the things that they realize they didn't know and they guessed at. But if you sort of struggled to type in the code in the first place, and it took you hours and hours to write a few lines of code, you hate to throw them away. And so you wind up feeling frustrated because it took me all day to write this and it doesn't work. And I legitimately feel the pain of this, that all of this effort and it's still not right. But I think there is a deeper level of permission to fail that is part of being a patient technology explorer, in that you know, or you need to be comfortable with, you're not going to get there, and you're not going to get there right away, and you're going to spend hours writing that first line of code and it's not going to work. So you're going to have to spend another few hours researching that line of code and then understanding something that you previously didn't understand, which is a kind of a failure. Learning involves unlearning the mistakes and unlearning the invalid assumptions, which is, again, a permission to fail, that there are mistakes that will be made and you'll make them. And you have to be sort of somehow optimistic about making a mistake. And I don't know where that optimism would come from, really, but I kind of feel that that's the thing that is hard to find sometimes, is how do I press on in spite of this pretty obscure thing? Tooling around this, and you had mentioned, is there a way in the ecosystem of tools to address this? Tooling is a sensitive issue because you can imagine having some really slick integrated development environment that's looking over your shoulder and trying to coach you on what those error messages really mean. And this is a potentially dangerous area because somehow or other, this looking over your shoulder software tool is trying to register your intent. And that can be really tricky because it may not be clear from the code what you were intending to do in the first place. And so the tool, in trying to square you away, may wind up misleading you because it made the wrong guess about your intent. So I worry a little bit about over-tooling in this area. But then on the other hand, under-tooling means people look at cryptic error messages and say, gosh, I can't do computer today. And I don't know where the middle ground would be. Is it possible to have some super clever assistant? Or would you need some natural language thing where you talked through the problem and the solution with some chatbot before you started coding so that the chatbot had some context and some sense of what you think the terminology means? And maybe that would be helpful. But gosh, doing sentiment analysis on some of these technical topics, fraught with difficulty. Since I get median and mean confused, even having me start a statistical project is going to be trouble because you know where it's going to go, nowhere good. And so I would need to talk to a real data scientist before I got started down something that involves statistics. And so tooling in that area, maybe not so helpful. You maybe need a tutor or somebody that you can, oh, wait, that's what Stack Overflow is. You ping your question, somebody tutors you.
And that goes nicely, too, into the idea of encouraging people to select a project that they're interested in, that they want to be able to work through, but then figuring out how you actually explain to them that wonderful website or that super cool robot that they want to build isn't really practical. It's actually going to require a decade and a whole team of engineers to be able to actually get anywhere near success. Why don't you set your sights a little lower? And so just being able to help illustrate what types of projects are actually reasonable and within scope and achievable in a short amount of time for them to be able to actually acquire the skills. But then also, if they are looking to take on a somewhat larger project, understanding what are the components that the overall project can be decomposed into, and what are the dividing lines, and how are you going to go from zero to complete, and what are the steps along the way?
Oh, yeah. That is, I believe, sort of the gold standard in the long run for how you understand the technology. It is being able to discuss it at a reasonably high level with a certain amount of clarity as to what the objectives are, what the information sources are, what the information target is, what the transformations are. This is all not obvious that it has to fit together this way. There's a lot of things where it's not clear that it's an information-based operation in the first place. You know, your robot example, I want a clever robot to do a better vacuuming pattern in my apartment. That's actually an information thing. What is the source of data for the robot? And it's an algorithm thing. And none of this is clear at first. It takes sometimes, I think, years of experience to figure out what the sort of roadmap through the intellectual space is. How do we talk about this and what are we talking about? I think that can be difficult for a person to sort of come to grips with. And one of the most important things that I think is not obvious at first is a great many pieces of automation are really supporting a person making a decision. It's not doing the thing, it's helping a person decide if the thing was done correctly or should the thing be done at all. So when you look at like ride sharing, like Lyft or something like that, a car pulls up. Do I get in? Do I not get in? These are questions that have to be addressed by providing a great deal of information to both parties in the transaction so that they're comfortable making a decision and then taking action. And so the fact that it's really information that helps a person decide what to do, it's sometimes hard to even frame the problem that way, so that you can then figure out what information they need, what transformations have to be performed, and how do I get it in a form that people can use it.
There's also the question of what the different levels of detail and guidance are that are needed for people as they progress along different stages of acquiring experience and understanding of these problem spaces, where if you have somebody who is completely new to programming technology, how do you keep them interested past the point of this is a function, this is a variable, this is how data flows through the program, because all they care about is being able to make a shiny new website to be able to impress all their friends or build a video game that they can play. And they don't want to know what the core building blocks are, but they have to be able to understand that. And then once they've gained enough experience to be able to say, okay, I've built, this Pac-Man clone, and now I want to be able to go on to building some shiny 3D, platformer game, acquiring that next level of capability. What are the differences in terms of how we need to provide guidance and provide motivation through those changes? Or is there a difference between the different stages in terms of how you keep people interested?
The question of is there a difference, that really hits at it, because I think a lot of these things are more of the same kind of things, that it's that very first step that's the hardest. Once the very first sort of glimmer of understanding of how this all works together is achieved, the rest of it may not flow at the pace you want, but it kind of flows. It's that first glimmer of what is the data in this problem, what is the processing in this problem, and who is the consumer of the data. These are hard things to reason about sometimes. And once you're sort of over the hump there as far as what is the data, who needs it, and what action are they going to take based on that data, then after that, it begins to become more clear how automation works and where automation fits into our life. The first few steps there of what is information and how do people use the information to make decisions, some of that is hard to get a grip on because so many things are so delightfully automatic and have been well thought out. You glance at your stove and you see the time. Somebody thought that all the way through. Like, what is the use case for an idle stove? And you, as the user, don't often think about, why did somebody decide that the stove should show me the time? That connection between what is the stove doing when it's idle and what is the stove doing when it's working, these are not obvious things. And it takes a bit of thinking about the problem space and the technology and what people do and why they do it. And this is difficult. But I think the very first step is just the core understanding of how does a person use a device. They supply some input, the device takes an action, but it's the person initiating and confirming and acknowledging. Understanding how that works, I believe, is a pretty big deal.
One of the other things to think about too, in terms of helping people gain understanding of how complex pieces of software work and how they can go from zero to complete, is the question of starting from the inside out versus the outside in, where do you start with functions and variables and data flows, or do you start with the complete application and then guide people through decomposing it and figuring out how things wire together at successively deeper levels?
That's a huge question, because having a goal-directed activity, looking at the total application, is how you keep people motivated. But as a practical matter, if you're going to learn the technology, you're going to have to start out with tiny little baby steps of defining variables and defining functions and figuring out how the Python with statement works and those sorts of things. And having the two meet in the middle is, of course, the goal. But, oh my gosh, it's so challenging to keep your eye on the prize when you're still trying to figure out what an elif clause does in a Python if statement. And your real goal may be environmental cleanup of the Chesapeake Bay, but you're still having trouble with elif clauses. So yes, there's a big gap there, and it's a difficult gap. And It is difficult to see how big problems are solved by lots of little bits of software. It's very much an art form, and I don't have great advice. All I know is that I start my books, almost all of them, with really very, very simple stuff before moving on to more advanced things, in the hope that people will get started on the right foot. They'll come to the foundations of the language sensibly and eventually see how to bridge the problem that they'd like to solve into this technology world that doesn't fit their problem very well at all. One of the fun problems that I found along the way was the carbon dioxide measurements from the top of Mauna Kea volcano in Hawaii. Years and years and years of weather data. Fabulous data set to analyze, reasonably clean so that you don't need to spend a lot of time fooling around with it. But you can see this dramatic uptick in CO2 levels, and you can take out seasonal variations. You can do lots of very clever, not very difficult statistics with that data set. It's a lot of fun for learning. But then there's this next question of, I want to solve a bigger environmental problem, and I'm kind of stuck looking at a small sample of data. I don't have great advice there, except keep pressing forward, keep pushing the envelope on the technology, keep trying to master new things.
As an author who is trying to help impart these skills, there's also the challenge of providing a structured approach to being able to understand what's happening, but also trying to present it in a way that is interesting and motivating for people who are reading, who might have different backgrounds, where your example of how to replicate the decision-making behavior of the Sorting Hat from Harry Potter isn't interesting at all. They care much more about something completely orthogonal to that. So how do you provide room for creativity and exploration while also providing enough of a structured approach to help guide people through understanding the technology that will actually help them solve the problems that they care about?
It's difficult to reach outside yourself, that is for sure. And so I'm sort of fortunate that I was a traveling consultant for a long time, so I saw a fairly large number of interesting problems. But the other side of that is some of those problems are really cryptically weird. And, the customer enterprise caused their own problem by doing some dumb thing 15 years ago, and we're still paying the prices for that. And that doesn't really translate well to a book on Python. It was fun. I learned a lot from it. I learned some Python skills, but the problem's kind of rarefied. So that was the downside of being a traveling consultant. Similarly, working as I do now for Capital One, some of the banking problems are things that are highly technical banking problems, and some are highly technical bank marketing problems. They don't translate terribly well, except to the tiny little community that's wrestling with it. But some of the sailboat problems are kind of general, and so they kind of be expanded into something that other people might find interesting. So I've sort of leveraged a bunch of those sailboat hobby problems, and they've been a lot of fun because I have to tease out the little nugget of Python programming goodness that's in there and leave behind a bunch of the other ephemeral things that collect along beside it. So that, I think, forces me to find something that's kind of recreational, not so serious, not so enterprise business stuff, but still has enough technical merit that it illustrates a Python programming principle reasonably well. One of the ones that I was looking at the other day as part of a second edition rewrite was this question of how far away two things are given latitudes and longitudes. There's like 3 different ways to compute that depending on exactly how much accuracy you need. And so that set of formulas is a thing that I have sitting on a shelf that I pull out periodically, because if you want to do floating point math, it's kind of fun. If you want to do some analysis of, 3D vector space, some of it can be fun. If you're going to do some statistical aggregation of the data, sometimes it can be fun. You hate to overuse the example, but on the other hand, it's an easy thing for people to visualize because, you look out over the water and say, how far away is that? That's an interesting question, and let's explore it.
This episode of Podcast.net is sponsored by Datadog, the premier monitoring solution for modern environments. Datadog's latest features help teams visualize granular application data for more effective troubleshooting and optimization. Datadog Continuous Profiler analyzes your production-level code and collects different profile types, such as CPU, memory allocation, I/O, and more, enabling you to search, analyze, and debug code-level performance in real time. Correlate and pivot between profiles and distributed traces to find slow or resource-intensive requests. In addition, Datadog's application performance monitoring live search lets you search across a real-time stream of all ingested traces from your services. For even more detail, filter individual traces by infrastructure, application, and custom tags. Datadog has a special offer for Podcast.net listeners. Sign up for a free 14-day trial at pythonpodcast.com/Datadog. Install the Datadog agent and receive one of Datadog's famously cozy t-shirts for free. As somebody who is working in technology and has a lot of history in being able to address these various problems and solve them and understand what is possible and what is practical, what are the shortcomings in the ways that we build and design technology that make that difficult to understand as to what is possible? And what are some of the ways that as technologists we can make that more approachable for somebody who does have some wonderful idea for how to solve something and requires some technological component to it, but then they hit this brick wall of not even knowing where to begin?
I feel that pain on a fairly regular basis, because there are some of these bits of sailboat technology that parts of it I just do not understand at all. And some of the more technical parts of understanding how the boat is put together, stuff like fiberglass. Like, I lived in a fiberglass house for 2 years and I understand zilch about fiberglass. So I very much feel the pain of somebody who's coming to an information-centric problem and wonders how all this information technology works. Because happen to be living in information technology space, I kind of get it as it's second nature to me. But when I come to fiberglass space, I have to call a professional and say, listen, I need this thing in my hull fixed. What are you going to do? And then they talk a bunch of fiberglass mumbo jumbo to me. I'm slowly getting a better feel for how that plastic technology of fiberglass works, but it's an uphill grind. And it gives me a sense of how other people feel about software. How do I get there? What are the fundamentals? So I try to use things that are foreign to me that I've had to learn on the boat as a way to help me understand how someone can be completely lost about something as simple as floating point numbers. It always amazes me that people are shocked by adding together 1/3 and 1/3 and getting an answer that the rightmost decimal place is not 0.66666, it's 0.66668. Where did that 8 come from? It seems obvious to me. It's not obvious to them, and all I have to do is step out of my comfort zone with the computer and think about my discomfort zone with fiberglass and say, oh yeah, really, there are a lot of questions here that need to be answered to make this floating point thing feel more comfortable to someone who's as lost around floating point as I'm lost around fiberglass.
Continuing on that, in terms of your own experiences of gaining new capabilities and new skills, particularly in the technical sector, what are some of the projects that have kept you motivated, and how have you overcome the hurdles in understanding to be able to decompose those skill acquisitions effectively?
One of the ones that I struggled with for a while and continue to struggle with, and I also use it as a kind of a lever for understanding other people's discomfort, is processing images. I take a picture with my phone and I upload it to my computer and I'm kind of done with it. There's tools on the phone that will do things, expanding a section or contracting a section or whatever. But I had a picture that part of it was almost unviewable, and I really wanted to look at it more closely. So I had to kind of teach myself about photo filtering using some of the Python packages that are out there to manipulate images. So that helped me also to understand where knowledge gaps arise, because I would kind of assume that pictures work this way. And then when you actually look at the data structure and look at the libraries available, it's like, oh, pictures don't actually work the way I think they do. What I think of as contrast in a picture isn't really exactly what's going on in there. So the coming to grips with the terminology is part of it. And so I try to write in that way for people who are reasonably knowledgeable about some things, but don't know about how this particular thing works inside the programming language, programming world, computer environment in general, but really how it's visible inside the programming language. What are the data structures and what are the algorithms? These are not obvious things, and I try to take my struggles and project them on things that I'm perfectly comfortable with. How would someone struggle with this? What do they need to know? What's the best way to expose it? It makes some of my books kind of long. We had an argument with one of the editors about one of these things that's 400 and some odd pages. But in the long run, I kind of win some of those arguments because it's difficult to find stuff that you can clearly cut out. Because for the person who's not already an expert, you need a little bit of background. And so the little bit of background expands to another example, which expands to an example that motivates that example so that you can then come to the real problem. So I'm more comfortable with that over the years. And, now that I'm at book number 9 or something, with providing sort of a lengthy buildup to more detailed, more practical kinds of things.
Going back to your point about getting comfortable with failure, for somebody who is writing a book, what are some of the ways that you can help convey that practice to somebody of, here's something that's broken, here's how you actually go about troubleshooting it and finding a solution?
That is sometimes difficult. This harkens back to the newbie who is very first wanting to learn to program because they think they have a good problem they want to solve, but this computer thing is kind of opaque to them. Some of these things can be challenging because it's not always easy to see how it's all going to fit together, where the person's role is and what actions the person takes, what decision the person makes, and what the response of the software needs to be to that. Some of that is right awful difficult. And I don't know that I really have a grip on that as a writer, because I know that there are times when I have really banged my head against the wall and written and torn it up and deleted it and written it all again. And still, the technical editors and the reviewers at Pact will look at it and say, Steve, this really does not make any sense. And they're absolutely right. Some of these things are hard, and you need to throttle back and say that, yes, I have a lofty goal, but I'm not going to be able to get there. So let me find a less lofty goal that might be more achievable. And perhaps I can cut that back down to a baby step that I can take and just totter forward a few steps and get something to work. And I think that's probably the only useful advice is to, when confronted with something that's really, really difficult, find ways to decompose it into the little baby steps, automate the littlest baby step first and see if you can expand from there, knowing full well that at some point you may wind up walking into a corner in all those baby steps and have to go back and say, well, what choice did I make? What choice did I make before that? Oh, wait. Before that, I made a bad choice to use the wrong data structure. So let's delete that code and start again using this other data structure. Frustrating to delete all those things, but it's how you learn. You walk down a variety of paths that lead to dead ends and then have to go back and try other paths that maybe don't lead to dead ends. But if you limit your goals to something very, very small, then each success is its own reward, and it makes it a little easier to move forward.
Yeah, definitely having those small wins at different stages can help keep people on track, where if they don't have any path forward to understand how to even achieve some small success, then they're going to be completely discouraged and give up and go learn painting instead. Not that there's anything wrong with that.
No, there isn't. In fact, in many cases, the mental break is a good thing. So between technology and sailboats, there's a giant gap because there's very little technology on sailboats. It's wind and water and a big Dacron fabric sail.
For anybody who is considering writing a book to impart some knowledge or skill to somebody, or for somebody who is looking to acquire some new technical capability, is there any particular advice that you have for them?
Giving yourself the freedom to explore, I think, is one of the biggest. I know some folks who struggle into dead ends and then don't know what to do. And I don't know, maybe they've imposed a schedule on themselves, or they've decided early on some constraints that are perhaps a bad idea. For instance, that it has to run on this laptop. Well, yeah, but maybe it's a big machine learning thing, and maybe you need to spend some money at a place like Google or Amazon or something for a big server for a few hours to do this project that would take a month on your home computer. Some of those decisions are hard decisions to make, and it can be hard to unwind a previously made decision. So the advice that I have for almost everybody is to try to maintain as much flexibility as you possibly can. Commit to very little and make sure that almost everything that you decide, you can undecide it quickly and go in a different direction. And I think the ability to undecide and change direction is the secret to mastering a lot of technologies. I believe that we stumble into these things with assumptions, and our assumptions aren't sometimes terribly helpful. What little I know about the fiberglass hull of my boat is probably all wrong assumptions. And each time that I talk to a contractor about some particular job, they improve my understanding a little bit because they basically invalidate one of my assumptions and cause me to have to learn something new. And I think that's true for any technology, particularly software technology, that some of it is difficult to visualize. And so you head into it thinking you know what you're talking about, thinking you know what you're going to build, and some of it is bad assumptions, and you need to be flexible. You need to be forgiving of yourself and try again later, differently, without cursing your idiocy. No, forgive yourself. You didn't know. You tried something. Let's try something different.
Reflecting back on your experience of working with Python over the past couple of decades, What are some of the ways that it has improved in your experience in terms of being more welcoming to newcomers or being more forgiving to failure?
This is a tough one. Python has grown so dramatically. By some metrics, it is the most popular programming language. And so when I started in the previous millennium looking at Python, it was kind of a nothing. The question back in the day was, you should maybe be looking at Ruby because it's a better language. I didn't agree at the time, and I don't agree now, but Python has swept up in popularity to a huge degree. So the availability of tutorials and the availability of exercises and things like that has just shot through the roof. And what I think people need to do, as with allowing themselves freedom to make mistakes, you need to allow yourself freedom to look at tutorials, look at documents, look at advice people have, and recognize that there's a lot of it out there, not all of which is addressed to your specific need. And so if you find something that seems unhelpful, discard it, move on, get the next thing. Because of the huge volume of tutorial material and the huge volume of training material on Python, it should be possible to find something that is appropriate for where you are as a learner or as a deep expert even, because while I may be a deep expert in the language, I know squat about statistics. And daily I am reminded about how little I know about the fundamentals of data science by my peers in the data science community. I mean, they're peers in the company, but data science-wise, they're not my peers, they're my mentors. And recognizing that gap is helpful because it shows me what I need to learn. And conversely, there are things they don't know about Python, so I can show them the things they need to learn. But I believe it's very important to be forgiving of yourself and to allow yourself the space to find your mistakes, switch over, do something different.
And are there any other aspects of this topic of staying motivated and acquiring new skills and helping other people to learn new things that we didn't discuss yet that you'd like to cover before we close out the show?
No, you have been super, super helpful and super thorough. This is a deep topic. I've been doing it for a number of years, but I think this has really been a fabulous conversation on acquiring and perfecting skills, which I think is, probably one of the most important things we can do as human beings.
Well, for anybody who wants to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. This week, I'm going to choose the combined trilogies of The Hobbit and The Lord of the Rings, both of which I just recently watched in the extended edition. So it's always fun to revisit those movies, and watching the extended edition and seeing the little scenes that weren't in the theatrical releases was fun to try and pick them out, and just a lot of good fun and really well-made movies. So if you're looking for something to keep you entertained for a few hours, definitely worth sitting down with one of those. And so with that, I'll pass it to you, Stephen. Do you have any picks this week?
I have two picks that are near and dear to my heart. And these are sometimes hard to find because these are kind of obscure old movies. Dr. Strangelove, or How I Learned to Stop Worrying and Love the Bomb, which is the full title, which is just, in one sense, an extremely depressing story about nuclear war, but in another sense is just a hilarious comedy of errors on the part of government officials. I absolutely love that movie because of that gross conflict between the fact that it's a comedy and it's a tragedy all in one package. I also like the movie because it's shot in a bizarro square format, like it was originally a 16 millimeter film or something made for, well, when I was a little kid, for school use. The sort of obscure weirdness of it offsets the black comedy as well as the epic tragedy that is all one thing in that movie, with just a fabulous performance by everybody involved. The other one is the movie The General by Buster Keaton. And it is also black and white, but that's just a coincidence. It just happens to be really, really old. like 1915 or something like that. It was a sort of a tragedy about the Civil War, but because it's Buster Keaton, it's filled with these insane physical comedy things that only he could do. So that, I believe, is perhaps one of the funniest movies I think I've ever seen. But interestingly, also a tragedy because a lot of people do wind up getting hurt when the train blows up at the end. Spoiler alert, the train blows up at the end. The physical comedy of it and all of Buster Keaton's physical comedy is just the most amazing thing.
Thank you very much for those recommendations. Definitely enjoyed Dr. Strangelove when I watched it. I'll have to take a look at the general. And I also appreciate you taking the time today to join me and share your experience as an author and a trainer in helping people to acquire and perfect new skills, particularly in the technology space. So thank you again for all of your effort on that front, and I hope you enjoy the rest of your day.
Thank you.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.